Assalamu alaikum students. Welcome back to another lecture on Introduction to Mathematics. This is your week one review of basic arithmetic operations and algebra. And this is unit 1.2. And in this unit, we'll be talking about ratios and proportions, right? So the topics that will be discussed in this unit are ratios. First, we'll talk about what a ratio is and uh, get a general understanding of it. And then we'll move on to proportions. So what are ratios? Ratios are basically comparisons that are made between two sets of numbers, right? So for example, if I were to say that there are 8 girls and 7 boys in a class, so what is the ratio of girls to boys, right? So what it means is basically you have to compare the number of girls and the number of boys, or the number of boys to the number of girls, right? So this is what a ratio is. So we'll say that since there are 8 girls and there are 7 boys, so I can say that the ratio of girls to boys is 8 to 7, right? This means that there are 8 girls and there are 7 boys, right? So this is what a ratio is. A ratio is basically used to make comparison between two sets of numbers. Now, this is a case of girls and boys. We can make any more, there are obviously other applications as well. For example, pay with hour, or for example, I'll see this right here, miles per hour, right? So what is miles per hour? Basically, this is a unit of speed, right? So if I say 100 miles in 1 hour, so this is again a ratio, right? 100 ratio 1. This means I can travel 100 miles in 1 hour, right? Again, ratios are used to find out the cost of items per pound. Like for example, uh, in Pakistan, we measure vegetables by, per kilo. Like for example, the cost of tomatoes is 60 rupees per kilo, right? So 60 ratio 1. For 1 kilogram of tomatoes, I have to pay 60 rupees, right? So the cost of items, of course, they're also a type of ratios, and the hourly rate of pay. For example, if somebody is paid 10,000 rupees per hour. So I can write it like this, 10,000 ratio 1, right? So ratios are basically, they're used every day, and they're used to make comparison between two sets of numbers. Now, you have to realize that there are 3 ways to write ratios. The first way is write the ratio using the word 2 between the two numbers being compared. Like for example, how we talked about girls and boys. For example, there are 8 girls and 5 boys in my class. What is the ratio of girls to boys? So I can say, since there are 8 girls and 5 boys, the ratio is 8 girls to 5 boys. The ratio is 8 to 5, right? So this is one way of writing ratios. One of the ways of writing ratios is to use the word 2 in between, 8 to 5. Or for example, if there was 12 boys and 10 girls, I can say 12 to 10, right? So this is just another way of, the first way of writing ratios. The second way is, which is the most preferred way, is to use a colon between the two numbers being compared. Like for example, there are 3 apples and 4 oranges in the basket. What is the ratio of apples and oranges? The ratio 3 apples to 4 oranges, I can also write it as 3 ratio 4. You have to pronounce it like this, 3 ratio 4. These two, this colon, it represents your ratio. Okay, so that is the second way of writing ratios. The third way of writing ratios is to write the ratios as a fraction, right? Now, for example, this is a long example, but Hunter and Brandon, they were playing football, and Brandon scored 5 goals and Hunter scored 6 goals. What is the ratio of goals Hunter scored to the goals Brandon scored? Now, Hunter, he scored, you'll see right here, Hunter scored 6. So the first item we have over here is 6, and ratio of Hunter scored to Brandon scored. Brandon scored 5 goals. So 6 ratio 5, right? 6 goals to 5 goals. And you can also write this as 6 by 5 right here, right? So this is the third way of writing ratios. So as you can see in these examples, basically when you're comparing any two sets of numbers, it could be girls to boys, apples to oranges, one person's score to another person's scores, we can use ratios to better, make a better comparison, right? Next up, what we need to realize is how can we reduce the ratios. Now ratios, they can be reduced without changing the relationship. 2 boys to 4 girls, what is the ratio? I can say 2:4, right? And 1 boy to 2 girls, 1:2. Now you might say that these are two completely different ratios, but they're not, right? 1 boy to 2 girl, this ratio is the same over here. If you reduce 2:4, how can you reduce 2:4? You can divide both sides of the number, both sides by the number 2, right? Divide this by 2 and you divide this by 2. So you get, sorry, this is 1. So 1:2 you get right here, right? So 2 boys and 4 girls, 2:4 is the same as 1:2, right? So these are what we call equivalent ratios, or basically this is how you can reduce the ratios, right? Now how basically every ratio that you find, it has to be written in their lowest terms. This is a property of the ratio, right? So let's take a word problem and we'll try to set up the ratio. For example, you scored 40 answers correct out of 45 problems on a test. Write the ratio of correct answers to total questions in the lowest form, right? Now whenever we are trying to make whenever we're trying to take out mathematical data from a word problem, it is important to read the problem carefully. We want the ratio of correct answers to the total questions, right? So how many correct answers I had? I scored 40 answers correct, right? 40 to total problems. How many problems? 45 problems, right? So 40 to 45 is going to be the ratio in this case, but this is not the ratio in its lowest term, right? 40 to 45, you can write like 40 to 45, 40:45, or 40:45. It's the same thing. Now how do we bring it to its lowest term? We'll be basically utilizing the use of HCF that we discussed in the previous slide. Now reduce the ratio if necessary. What is reduce? Reduce means to break down a fraction or ratio into the lowest form possible. So whenever you're reducing, the operation will always be division. You have to divide 40 and 45 with some number. So whenever you have to reduce the ratios, it is better to set up the ratio in the vertical form, in this fraction form. And now what you have to do is find out the HCF of 40 and 45, the number that divides, the highest number that divides 40 and 45 both. How do you do that? You find out the factors of 40. These are the factors of 40: 1, 2, 4, 5, 8, 10, 20, 40. And you find out the factors of 45: 1, 3, 5, 9, and all this, right? So the highest common factor you find out is 5, right? So you divide both of these numbers, 40 and 45, by the number 5. You divide 40 by the number 5, what do you get? 8. And you divide 45 by the number 5, you get the number 9. So 8:9, right? Or 8/9. Basically, this is the reduced ratio, right? 8/9. 8/9 is the same as 40/45. Basically, what I'm trying to say, but 8/9 is the reduced form of 40/45. Let's take another example. There are 26 black cards in a deck of playing cards. If there are 52 cards in a deck, what is the ratio of black cards to the deck of cards? So ratio of black cards to the deck of cards. What are the number of black cards? We have 26. So we write down the number 26. And to the deck of cards, the total number of cards in the deck, and those are 52 cards, right? So 26 ratio 52, this is your ratio. Okay. Now do you think the ratio can be reduced? 26 divided by 52, do you think it can be reduced? Actually it can be. You can find out again, you can try to find out using the HCF, or and when you do these enough, you'll get a basic intuition of how you're supposed to do it. So 26 times 1 is 26, and 26 times 2 is 52. So the ratio can be reduced to 1/2, or 1:2, right? Okay, so this is this is how you're supposed to reduce the ratios. Now let's talk about what a proportion is. A proportion is basically, now we include equations into this. So a proportion is an equation that says one ratio is equal to another. For example, if I have a ratio 3/4, right, and if I have a ratio 39/52, Now these are two separate ratios, right? And if I say that these two ratios are equal, right, then this whole thing, this is a proportion. And these two ratios, they are equal. If you simplify them, you might be able to get 3/4. But the main thing is that this is what a proportion is. When two ratios are equal, you get a proportion, right? So if, how do you find out if a proportion is true or what a true proportion is? You write them like this. You have a ratio 4/5, right? And then you have another ratio 20/25, right? And then you cross multiply. What does cross multiply means? Basically, you take the numerator and you multiply it with the denominator of the second ratio, and you take the denominator of the first ratio and you multiply it with the numerator of the second ratio, right? And then you try to solve them. 4 times 25 is 100, and 20 times 5 is 100 again. So this is a true proportion, right? The cross products were equal, therefore 4/5 and 20/25, they make a true proportion. And now we have these some examples, and we need to find out whether these proportions, they are true or not. So how do you do this? They are solved in the next slide. This is the case, 3/5 ratio 15/25, right? So you multiply 3 with 25, what do you get? 75. And you multiply 15 with 5, you get 75. So this is a case of a true ratio. Similarly, this again is also a case of true ratio. Let's take a look over here. 7 times 60 is 420, and 12 times 37 is 444. So 420 is not the same as 444. So this is a false ratio. This is a this is a false proportion. I'm sorry, I meant to say this is a false proportion, not a false ratio. Right? Now, proportions are used whenever to solve word problems. Basically, I'll just give you a hint of how these word problems can be. They're like this. Like, for example, if Ali was traveling in a car and he traveled 20 kilometers in 1 hour, then how many kilometers will he travel in half an hour? You know, so this is basically the an example of how the word problems of proportions can be. And so we'll be solving these proportions with variables. Now, what is a variable? Basically, variable is like x or the number a, or basically any letter that we can use. A variable is any letter that takes the place of a missing number or information. So let's take this example. Eric rode his bicycle a total of 52 miles in 4 hours. Riding at the same rate, how far can he travel in 7 hours? Right? So we have a ratio from this, 52/4, right? We can make a ratio from this. And when they tell us that we're riding at the same rate, this basically means we can equate this with the other ratio. This, how far can you travel with 7 hours? Let's take a look at how we're supposed to solve this, right? So the first step is look for the two sets of ratios to make up a proportion, right? So the first set we already know is 52 miles in 4 hours, right? You have 52 miles in 4 hours. This is the first ratio. So 52/4 or 52/4, this is your first ratio, right? Next, the problem states how far can he travel in 7 hours. The problem is missing the miles. Like, we have to find out how many miles he traveled, right? So we can, the miles that he can travel in 7 hours, we'll call that n, right? Or we can call it x, or we can call it a, or we can call it m, whatever, right? But we'll use the number n. This is what a variable is, right? So we'll say he can travel n miles in 7 hours, right? So this is the second ratio, this is the first ratio, and the proportion should be set equal to each other, right? So 52/4 is equals to n/7. Now we have to solve this. How do you solve this? We're assuming that this is a true proportion, so we'll have to cross multiply. 52 multiplied by 7 is equals to 4 multiplied by n. This is done in the next slide. Cross multiply, divide both sides by the number connected to the variable, check the answer to see if it makes a true proportion. So when you cross multiply, what do you get is 4 times n, which is 4n, and 52 times 7, which is 364. If you have any, if you have any experience in working out with equations, you'll know that in order to take out this 4, you have to divide both sides with the number 4, right? So you divide 4n by the number 4 and you divide 364 by the number 4 and you get 91. So basically the value of n is 91. So what this means basically is that he can travel 91 miles in 7 hours, right? Now, how do we know if this answer is correct? Put this 91 back over in the place of n and you cross multiply and the answers are correct. They're both equal. So this is a true proportion and your answer is correct, right? Similarly, we have another example. Justin's car uses 40 gallons of gas to drive 250 miles. At this rate, approximately how many gallons of gas will he need for a trip of 600 miles? Now we have gallons of gas and the distance, right? So he uses 40 gallons and he travels 250 miles. This is the first ratio. And he uses, we have to find out how many gallons of gas will he need, right? So that I'll call it X gallons. So he uses X gallons to travel 600 miles. Now this is another ratio, and then you equate them each other to get a proportion, then cross multiply and solve for X. You'll get the value of X as 96. You try out again and you find out that both numbers are equal. So this is the correct value. So basically he will need 96 gallons of gas to travel 600 miles, right? So this is basically what ratios are and what proportions are, and how you can use ratios and proportions to solve word problems and find out some uh, information from this. And I mean, these types of questions you need to find. I mean, you face these questions with every day in your life. Like, if I can travel this much distance in this much time, how much distance can I travel in this much time? We all make these certain mental calculations in our head. So we need to have a concept of proportion whenever we're solving these cases. This is it for this lecture, and I will see you inshallah in the next lecture.